In this video, we'll be covering a popular open source monitoring tool called Prometheus. And the aim of this video is to show you all the terminology, we'll walk through the documentation, show you what Prometheus is and why it is so popular, how to use it, how to configure it, and how it is used. Prometheus is a solution that helps us not only gather, but also query and store metrics. Metrics of applications, virtual machines, open source software, and a lot more. I'll also take you through the architecture, all the terminology, and basically just simplify it. And we'll walk through a couple of demos. We've got quite a bit through, so without further ado, let's go. Prometheus takes us all the way from gathering and generating metrics all the way to insights. It has a very powerful data model, which allows us to run powerful queries, and it has great visualization, especially when you use something like Grafana on top of it. And it is also a highly efficient storage. And the cool thing about Prometheus metrics and why it's so popular is metrics is very efficient. A metric has a name, and then it has key value pairs, which means a metric can be really small to store, and it allows us to store dimensional data. We'll take a look at the metrics types in a bit. The other cool thing is that Prometheus is a time series database, so we can track metrics over time. Things like requests per second, or things like request latency. There are also many client libraries available for almost every programming language, as well as many integrations. This means that almost all products and open source software has the capability to turn on metrics. So we can then use Prometheus to scrape those metrics. Things like HA Proxy and Nginx, and all your favorite open source software generally supports metrics. Even things like Kubernetes allows us to gather metrics of containers and pods and nodes. We can also use Prometheus to scrape metrics on cloud products and cloud infrastructure, like EC2 instances and virtual machines. If we start with Prometheus.io, the website, we can go to the documentation section. This will take us to the overview introduction on what Prometheus is. It's an open source monitoring system, and it also allows for alerting. I've covered some of the key features, which is multi-dimensional data model. The data model makes Prometheus metrics really efficient to store, lightweight, doesn't take up much space. And it also comes with a PromQL, which is a flexible query language. I'll show you a little bit about the query language in a bit once we have some metrics collected. Prometheus mainly operates on a pool model over HTTP. I'll show you what this looks like, but it means that Prometheus pulls metrics from endpoints. Those endpoints can be your containers, your pods, your virtual machines, can be applications like proxies, reverse proxies, load balancers, and so forth. It can also be databases. There are also capabilities to push metrics as well using an intermediary gateway, and I'll show you this in a little bit. Now, what are metrics? Basically, in layperson terms, metrics is a time series that refers to the recording of changes over time. So if you're running something like a web server, it could be something like requests per second or request time, how long requests take and how many requests we are receiving. If it's something like a database, it could be how many queries are running on the database, how many active connections are there. It can also be something like CPU usage on a virtual machine, or memory usage that you'd like to track over time. When your web application is slow, you can use something like metrics to work out where the bottleneck is. Now, Prometheus is also made up of multiple components. The first component is the Prometheus server itself. Prometheus allows us to scrape metrics from various applications, software, infrastructure, whatever is exposing those metrics. Prometheus can go out and scrape it. So we'll take a look at the scraping mechanism. But also, Prometheus is a time series database. So it also not only scrapes, but it also stores those metrics. It can store the metrics in memory as well as dump it to disk, which allows to save space and memory, and we can also store metrics longer term. Prometheus does have a separate solution for storing metrics longer term, term though. The cool thing about Prometheus is that because it's a time series database, it doesn't rely on external databases. So we don't have to worry about running a SQL cluster. And it also allows to distribute to other Prometheus instances to make it highly available. Another component is the client libraries. Prometheus comes with a whole bunch of client libraries. We'll take a look at some examples. They could be for C#, .NET, they could be for Python, Golang, Node.js, JavaScript, and more. This means the client libraries are available for many open source developers and vendors to use. So I mentioned that Prometheus can go out and scrape metrics, but what about jobs, cron jobs, and services that are not available for scraping? Prometheus also comes with another component called a push gateway, which allows jobs to push metrics to a gateway where Prometheus can scrape it. Prometheus also comes with special exporters for software that is not supporting Prometheus metrics by default. We can add an exporter to that software and allow it to export metrics. There's also another component of Prometheus which is called Alert Manager, which allows us to trigger and fire alerts to things like Slack, Microsoft Teams, or email. Let's take a look at the architecture. Now in the documentation, they also describe the architecture, which shows the Prometheus server. It has a retrieval component that can go out and scrape metrics from various exporters, or these could be microservices, containers, pods, it could be EC2 instances, virtual machines, any kind of Prometheus compatible target that is exposing metrics. Here we see the time series database that can also write metrics to disk. We also see an HTTP server which allows things like Grafana to connect to. And Prometheus also exposes a web UI, which we'll take a look at in a bit. Now for Prometheus to retrieve metrics, we need to configure what's called scrape configuration. And if you're running something like Kubernetes, where services can come and go, it can be difficult to manage configuration files. That is why there is a service discovery mechanism for Kubernetes available. We'll talk about this in a little bit. But Prometheus has pretty good integration with Kubernetes. And then we have Alert Manager, which allows us to push alerts to, and they can be distributed to things like PagerDuty and email. So to simplify this, I've come up with a diagram. The main box over here shows all the Prometheus components. Now I mentioned Prometheus comes in with a built-in scraper. It's a time series database and it has a web UI. So users like engineers can log into the UI to look at Prometheus configuration. So we can actually use the UI to troubleshoot Prometheus. It's very useful for that, and we can also write queries to test Prometheus and test the ingestion. Now if we take a look at the far left side over here, we have apps, we have VMs, we have Kubernetes. This can be any type of app. So it can be apps that our developers write, it can be apps that run in containers inside pods, it can be running in Docker, it can be running on a virtual machine, it can be any type of open source software that has a metrics enabled endpoint. So basically apps have an HTTP endpoint called /metrics. That's the default endpoint that Prometheus will look for. We can also have virtual machines. If you want to monitor things like virtual machines, you can install something like Node Exporter on those virtual machines, or EC2 instances, or physical machines. Node Exporter will also create a /metrics endpoint on localhost, which you can allow Prometheus to scrape. This can also be any compatible cloud infrastructure as well. Then we also have Kubernetes metrics, things like the Kubernetes API server, kubelets, kubestate metrics, and so forth. So as you can see here, anything that has a metrics endpoint that supports Prometheus compatible metrics can technically be scraped as long as Prometheus can reach that endpoint. If you have software like certain apps that cannot expose a metrics endpoint, you can use a push mechanism to push metrics instead, and you can push that to a gateway. This could be because of limitation with the apps or the software, or it could be for security reasons Prometheus cannot reach this app. This app could be running in a private network, so you can have this app push its metrics to a push gateway, which is also a Prometheus product, and then Prometheus can come and scrape the push gateway to get the metrics. So this allows you to work around things like network security. You can also use a push gateway if you have other Prometheus instances that wants to push metrics out. You can use this model to distribute metrics between Prometheus instances. And all of this scraping is controlled by the scraper, which is configured by this thing called the scrape config. We'll come back and take a look at the configuration in a little bit. Prometheus also supports another configuration called remote write, which allows Prometheus instances to send data elsewhere. You could be sending this to some external storage, like a third-party monitoring solution, something like a New Relic or a Datadog. You can send it there, or you can send it to another database, or you could even send it to another Prometheus instance. This allows you to make Prometheus highly available. If we jump back to the documentation, there's a section on concepts and you'll find the data model over here. This talks about metric names and labels. And basically a metric looks like this. You have the metric name and then you have label name and values. So you could have a metric name like CPU usage, memory or disk IO or network usage or some sort of custom metric. And then the label name could be like the name of the application, whether it's a pod, a container, running Docker, or running on a virtual machine, or running as a function app. And then the metric allows you to have multiple of these values. Here's an example of an API. You could have a microservice with API request total, and then you could have fields like the method was a post, so an HTTP post, and this is the handler or the URL or the endpoint of that service that was called. So that's how metrics are structured, and then you have different types of metrics. You have a metrics called counter, and a counter is just a single monotonically increasing counter number. So think of counters if you want to count the number of requests your microservice gets. You can use a counter for that. And this is where the client libraries come in. For microservices written in Go, Java, Python, Ruby, .NET, or Rust, you can use the appropriate client library to create these counters. Now, counters are specifically for numbers that keep increasing and not decrease. If you want to have a number that decreases, you'd use something like a gauge instead. And a gauge is a metric that represents a single numerical value that can go up and down. Think of gauges as values like temperatures that go up and down, or current memory usage, or things like concurrent requests. For that, you also need a client library for these different programming languages. And then finally, we have what's called a histogram. That is the third type of metric that Prometheus allows us to create. A histogram is a little bit more complicated because a histogram samples observations and counts them in configurable buckets. So a histogram has a base metric name just like the other metrics. So you can have a metric name called request latency, and this metric will expose multiple time series for each scrape. So it'll have cumulative counters for each of the buckets. It'll have the total sum of all observed values and the counts of events that's been observed. And then basically you'll use a function within Prometheus to work out things like latency or how long a request took. You can even calculate things like percentiles and averages, so you can get the average request time. Histograms are often used by functions in programming languages to work out how long a function took to execute. I'll show you some example metrics for each of the programming languages. But first, let's get a Prometheus instance up and running. Prometheus is very easy to run. You can download the binaries, which is basically just an executable that you can start up and give it a config. It also has a default location where you can just simply place a config and it'll read it from there. Now, the easiest way to run Prometheus is to use something like a Docker container. So what I've done in this example, I've created a Docker compose file that we can simply start up a bunch of services. But I want to walk you through each of the different types of service, show you how they create metrics, and then I'll show you the configuration file for how we can configure Prometheus to scrape these applications. This is extremely simple to set up if you have a bunch of virtual machines, you've got your own infrastructure, you've got on-prem, or you're running a bunch of cloud servers, or you're just running a home lab and you want to instrument and collect metrics. If you're running something like Kubernetes, you want to check out my service monitor guide, because configuring Prometheus configuration manually in Kubernetes is a little bit more cumbersome. So instead of having to touch the Prometheus config every time you create a new service in Kubernetes, you instead use something called a service monitor. A service monitor is a small YAML object that points to a Kubernetes service and a port. And when you kubectl apply a service monitor, it automatically goes and configures Prometheus and starts scraping that service. So it's basically a way to configure Prometheus, but using native Kubernetes YAML. Check out my service monitor video on the channel. I also have videos on the channel on how to run Prometheus in a Kubernetes cluster and monitor a Kubernetes cluster. Let me know down in the comments below if you'd like to see more of that in a future video. So installing and running Prometheus is very straightforward. If you take a look at the documentation, jump from the concepts page into Prometheus server, there's a getting started section, which points you to the latest release that you can download, and you simply extract that download. Then you need a config file, and once you have a config file, you can just start Prometheus by using the command line like so. You start up the Prometheus binary and point it to a config. Now, to make this process really straightforward and simple for you to try out, I've created a small Docker Compose file and a guide that you can use to run through the same demo. So in the link down below, you'll find a link to the Docker Development YouTube series GitHub repo, and in there you'll find a monitoring folder, and in the monitoring folder you'll find a Prometheus folder, and in there you'll find a README. This is just a simple README to show you how to set up Prometheus application monitoring, where you'll start up a Prometheus instance, start up a Grafana instance, start up a container that populates some dashboards for you to take a look at, and then you can start each container that you prefer. This is a Go application, a Python example, a .NET, C# example, and a Node.js example. You can then go ahead and generate traffic for each one of these applications so you can see statistics, and then log into Grafana to look at those statistics. You can use Grafana to go ahead and examine some of the dashboards so you can see Prometheus queries and what they look like. We'll take a look at all of this in a bit. You'll find all the source code in the monitoring folder under Prometheus. There's the .NET app with its source code and its Docker file, the Go app, Docker file and source code, Node.js, source code and Docker file, and Python, source code and Docker file. I also have a pre-made Grafana dashboard which we can simply import. And right here I have a Compose file. We'll start taking a look at that. Running in Docker Compose makes it really easy for you guys to run this locally because you don't need Docker run commands. You can simply say Docker Compose up, or you can run it in sequence and selectively start services you want based on the README. Firstly, we have a Go application. It tells you how to build it. It exposes port 80. Then we have a Python application. It shows you how to build it, and Python runs on 81. And then we have a .NET application, shows you how to build it. It runs on port 82. We have Node.js on port 83. And finally, we have Prometheus. Now, what I'm going to do is I'm just going to run the Prometheus image that's available on Docker Hub. So the image name is Prom, and it's running Prometheus version 3.3.0. I also give it a container name. This is important because in Docker Compose, if we want to run something like Grafana and we're importing a data source, as we're doing down here, you can see data sources and dashboards. We want to point Grafana to the Prometheus container automatically. So we need a container name, and I'll show you that in a little bit. We're going to be exposing Prometheus on port 9091. The default port is 9090. So we're going to start up our container by passing in a command, and this is a special command for Prometheus to tell Prometheus what config file to use, and we're going to tell it to use the config file under etc Prometheus, and we're going to call it prometheus.yaml. We're also going to mount that config file into that location. So this allows us to pass our own configuration to Prometheus, and ultimately what we do in Prometheus is we set up a scraper. The scraper is the component we saw in the architecture diagram.
It's beautiful.
Now, if we take a look at the documentation once again, you'll find a configuration section, and you're interested in the config section, and this will take you through each component and its meaning within the config file. Notice on the right hand side here, we have a scrape config. This is the main configuration of Prometheus that tells Prometheus what to go and scrape. So when taking a look at our diagram, that's this component right here. And this is kind of how we set it up. So under the scrape config, we create multiple jobs. Generally, you want to create a job per application. So here I have service A, and a service metrics endpoint is generally exposed by HTTP, but it can also support HTTPS as well. That is why there are different sub-config items here, like TLS config. TLS config can be used when you want to configure a TLS certificate like a CA, a cert file, or some key file. Basically, a TLS configuration that is used to go and scrape a service that is running HTTPS instead of HTTP. You can also have something like an HTTP config if your service is protected by authentication, like HTTP basic auth. In this example, I have a basic service that is accepting a username and password. Now, these mechanisms are basically used a lot of the times in open source software, things like the Kubernetes API service. A lot of these internal Kubernetes resources run on HTTPS. So that's how you would end up scraping those. And then you have a section called static config that has a list of targets for that job. And here you can set up the endpoint, so the IP address, it could be a local Kubernetes service name, it could be a VM name, it could be a name of a server on your home lab, it could be a private IP address, it could be any kind of endpoint. You can see I'm hosting my services internally on port 5000. We'll take a look at my example config, but this just gives you an idea of how the scraper works. And it can get quite technical. You can see we've taken a look at scrape and HTTP and TLS config, but there's also OAuth, there's Azure Service Discovery, there's Docker, OpenStack, Google, GCE, there's Kubernetes Service Discovery, and a bunch more. So that's an overview of the Prometheus configuration. So let's take a look at our configuration. In the source code under monitoring Prometheus, I have all my applications and my Docker Compose, the README, and then I have this Prometheus.yaml, which we will take a look at. And this is pretty much it. I have some global settings, so you can set up things like scrape intervals, how often you want to scrape. The more often you scrape, the more data you would collect, but also the more noise you might create over your network. That's the downside, but the plus side is you will have more accurate counters. Think about if you're tracking things like requests per second, CPU values that are quite sensitive. If you scrape them every minute or every 2 minutes or every 5 minutes, you can optimize on costs, but you might miss out on CPU spikes because CPU can be quite spiky. So that is the trade-off when using metrics. You want to scrape as often as possible, but not too often. Generally in Kubernetes environments, Prometheus is configured to scrape every 30 seconds. The next value is called evaluation interval. It's not that important, but it determines how frequently the server evaluates rules, which are used to create new time series and generate alerts. The important part here is our scrape configs, which defines our scraper. Here you can split things up. You can create multiple jobs, one per application or service. In my example, I just created one job and I created these static configs, which is an array of endpoints. That's what this targets basically means. And here I'm pointing to each of my applications on port 5000. In a Kubernetes environment, you'll generally see these targets being generated and they'll point to Kubernetes service endpoints. That is if you're using something like service monitors. Service monitors, as I mentioned, is a small YAML file that points to a Kubernetes service. When you apply a service monitor, the Prometheus controllers within your platform will come automatically and generate the static config. And you will generally see a job per service monitor. So that is my Prometheus configuration. If we take a look at each application, they all run internally on port 5000. You can see that over here. That means that each one of these applications will run port 5000, will be accessible by Prometheus, and they all have container names as well. Giving a container name in Docker Compose gives them a DNS entry, so all these containers can address each other. That means I don't need to use public IP addresses. I can refer to the container names like so, similar to Kubernetes service names. So what I'm going to do is I'm just going to start up all these microservice applications. So what I'm going to do is just grab all of these Docker Compose up commands, jump to my terminal, change directory into the monitoring Prometheus folder, do ls, we can see everything is here, there's our compose. Then I go ahead and just paste. That'll build each of the containers and start them all up in the background. If you do docker ps, you can see you have the Go, Python, Node, and .NET applications running. Then what I can do is open up the browser and then open up each of these URLs and generate some traffic. So here I have one endpoint, port 80, I've got port 81, I've got port 82, and I've got port 83. Now our applications are basically running and they have a metrics endpoint and they have some metrics sitting there. So to scrape and gather these metrics, I'm going to go ahead and start up Prometheus. So I'm going to say Docker Compose up Prometheus. Go ahead and copy that. Going to jump to my terminal and paste that. That'll start up Prometheus in the background. You can do docker ps to make sure it's up. We can see it right there. Then we can head over to the browser and open up localhost port 9091, and when we hit that, we'll land on the default query page for Prometheus, and here we can start typing to search for metrics, and you can start typing any metric name you're expecting. So if I type .NET, we can see there's .NET ones. If I type Node.js, we can see there's some Node ones. Here are some ones I've generated. If I type Go, we can see there's Golang and Python. We can also go to the status page and look at target health. So we can see here we have our targets. So you would technically use this page to troubleshoot Prometheus configuration. If Prometheus is scraping or not scraping, or you're not seeing your metrics when you search for it here, you know something is wrong with your Prometheus config. You can check the Prometheus logs. It'll generally log and it may crash when the config is invalid. But if there's a problem with a target, you will find it over here in the target health page. You can see we have all our targets and they're all green and up and running. It'll give you messages here like connection refused and useful HTTP messages if there's any issue. So this is a very useful dashboard for troubleshooting your metrics. Make sure they're populated here and make sure your targets are healthy. And that is basically the job done for Prometheus. You can write some queries and test everything in the Prometheus UI, but generally for visualization, you would plug in something like Grafana. So in this demo, I've stitched up a Grafana instance in our Docker Compose, and I do have a small helpful Docker container, which is going to inject some dashboards. If we jump back to our Docker Compose file, you'll see I have a Grafana service here, and I'm running the official Grafana image. The latest one at the time is 11.6.1. It's exposed on port 3000. In this example, I'm turning authentication off because it's just for demo purposes. And then I have another container which is just running Alpine, and what this does is it basically will wait for Grafana. It's an Alpine container that runs a small shell script. It installs curl. It basically just sleeps for a bit to make sure Grafana's up and running. There's nothing fancy here. If Grafana takes too long to start up, we might want to increase the sleep timer. Generally not something you would use in production because there is a race condition here, but I use this just to make it helpful for this demo. And this allows me to write a small script, so I can say curl, and I can run a curl command to the data sources API as well as the dashboard API of Grafana. And I can send it some JSON, and I'll be sending it this data sources and dashboard.json. These JSONs can be found in the source material under the Grafana data folder. To start up Grafana, it's really easy. We just say docker compose up -d Grafana. Jump into the terminal, I go and paste that. That'll start up Grafana, and then I can go ahead and run the dashboard container as well. So if we open up another browser tab, we can go ahead and navigate to localhost 3000, and that will take us to the Grafana landing page. page. We can open up the side menu over here, click on data sources. You should see the Prometheus data source automatically imported by our container. That is why this is useful. You can see it's pointing to Prometheus on port 9090. If I click that and I scroll down right to the bottom, we can say save and test, and you can see it works. Then we can also click the menu again, go to dashboards, and we can find this application telemetry dashboard that I created. Over here is a small panel for each programming language. You can click that and it'll show you the metrics over here for .NET Core, Node.js, Golang, and Python. And if you're interested, feel free to click on this panel and you can click on edit, and you can even see the queries and how to query each of these different types of Prometheus metrics. How do you query a histogram versus a counter versus a gauge? So that is the Prometheus overview and architecture in a nutshell. How to instrument applications in different programming languages, how scraping works, how the overall metric collection works, and how to query and visualize it in something like Grafana. Check out the link down below to the source code and try it out for yourself. And let me know what sort of videos you'd like to see in the comments down below. And if you're keen to follow along, I've got an ultimate DevOps course in the making. Check out links down below to the social media pages to follow along, as well as the link down below to the Ultimate DevOps course. And if you liked the video, be sure to like and subscribe, hit the bell, and if you want to support the channel even further, be sure to hit the link down below to become a YouTube member. And as always, thanks for watching, and until next time, peace.